Hello, everybody. This is Mrs. Wild from WCA Physics A. We are looking at Unit 5, Lesson 2 on centripetal force. Our keywords today are acceleration, centripetal force, and force. And I'll just be kind of going through the lesson with you and hopefully clear up any confusion you may have. So we're talking about centripetal force, which is basically just circular, force in a circular motion system. And remembering that force is any push or pull that causes an object to accelerate. Keep in mind the definition of force is mass times acceleration, and that is according to Newton's second law. So remember also with acceleration is change in velocity. They put in here change in speed, but I would literally change that to change in velocity. As you know and I know, speed is a scalar quantity and velocity is a vector because it includes direction of motion in there. So even if we don't have a change in speed, we're maintaining a constant speed, if we're changing direction, acceleration is actually happening. So we're looking at this person swinging a cup that's tied to a string in a circle. The only reason why the cup continues in the circle is because she's pulling on the string. The amount that she pulls on the string is the centripetal force. If we were to cut the string, the cup would fly off in a line tangent to the circle. That's because the cup's momentum is always tangent to the circle. In other words, the inertia of the cup will keep it moving in a straight line forever and ever, Newton's first law, right? And so we can say that its mass plus its velocity will continue in that straight line of motion because that was the direction it was moving when the string was cut. Moving on to the second slide here. If you swing an object on a string around in a circle, it says, you can feel the result of the centripetal force on the string's tension. So that's something you're going to experiment with a little bit later in this lesson. Actually feel it, because I think that's an important part of really understanding it. And also keeping in mind that there are 3 different factors that will impact how much force you need to put on that string. The weight that's attached to the string, how fast you want it to go, and how long that string actually is. And that is represented by this formula. Centripetal force, Fc, is equal to mv squared, mass times velocity squared, divided by r, which is the distance from the object that you're moving to your hand. That's the radius, essentially. Also use your scientific, your SI system of measurement here. So force is measured in newtons, mass in kilograms, velocity in meters per second, and radius in meters. What this picture is showing you is like the factors that affect the acceleration. So acceleration is how much it has moved or changed the direction of, right? So in this particular example, if we compare this one to, let's say, this one here, if we are swinging it faster, for example, let's look at this stone is in this position, and after 1 second, it is here. It starts off following this red dashed line, and then when it's in this position, it's following the little black line. It has changed by this amount. That's the difference, the angle between them. If I change how fast I'm swinging it, it's going to be able to move farther in the same second. So now the angle has changed more so we can see a greater acceleration. If it's a shorter rope or shorter string or whatever, it can actually move through the distance quicker. So we have a greater acceleration here as well. So you can see a bigger angle because the circle is smaller than the circle. So then the angle is going to be slightly greater here. So that's kind of represented in this formula. The other thing, and we'll come back to it in a second, that force is calculated by mass times acceleration. And it says, what is the direction of its momentum? And we said a straight line tangent to the circular path. We went through that already. In what direction does the object accelerate? That's always going to be towards the center. And this is the other one that you need to go back to that formula for. If the velocity of an object moving in a circle increases by a factor of 2, how will the centripetal force change by a factor of 4? Because if you go back to this formula, if I increase my velocity by, say, by 2, let's say the initial velocity was 2, 2 squared is 4, but if I increase the velocity to 4, so I'm doubling the velocity, 4 squared is 16. That's increasing the force by a factor of 4. Now the word is centripetal with a P. There is another word called centrifugal or centrifugal that you might see, which is not a real force. It's just something you feel when an object is moving in a circle. So just make sure you use the correct word, even though the incorrect word keeps wanting to go out of my mouth. All right, so this is comparing that centripetal force to gravity. So if we have a planetary system, the sun pulls on the planets much like your hand pulls on the string, right? And it is that force that connects the sun to the planet. The gravitational force is like the string that is connecting your hand to the cup. If the planet is more massive, the sun pulls harder, just like if the cup is more massive, you have to pull harder. The closer a planet is to the sun, the more gravity pulls on that planet, just like the shorter the rope, the more you have to pull on the rope to get it to continue. The faster the planet moves, the more you pull. So it's very analogous. One other thing I failed to mention earlier is that centripetal force is balanced by tension. So if centripetal force is pulling toward the girl, the tension on the rope provides an equal and opposite force. If the tension on the rope is greater than centripetal force, the rope will snap. So this is where here we go. You're going to be doing kind of an experiment. So what I would like you to do is just cut some string in various lengths to have some objects to tie to the string, and you're going to kind of experience what centripetal force feels like. Try to swing heavier objects, lighter objects. Don't go too heavy. You don't want to hurt anybody. Try to swing it faster, swing it slower. Try to have a longer string, shorter strings, and see how much force it requires of you to make these objects swing in a circle. You should be able to feel those types of relationships, right? That the shorter the string, the more force it takes, the heavier the object, the more force, the greater the velocity, the more force. All these things you should be able to feel. Centripetal force is similar to gravity because they both point toward the center. And the three factors that will affect are the ones in the equation: mass, velocity, and radius. Here are some questions about the experiment that you did, and then the next slide is your quick check. That's all I have for this lesson. If you have questions, let me know. Otherwise, have a great day. Bye-bye.